Now, in my video, why is your condensing boiler not probably condensing, I talked about a secret weapon, what there is, what people can have easily installed for not very much money that will help them save on their gas bill. And I had this little red tin, and in the little red tin, I had the secret weapon. So what was it? Well, it was this little device. So what was this little device? Well, let's get on with it and find out exactly what this little device is, how we installed them, and how they are going to save you gas. Now, if you watched the video, you'll know exactly what this is. And if you didn't watch the video, why not? But if you didn't, I will leave a link in the description down below so you can watch that video after you've watched this one. Now, on the 6th of April 2018, they made changes to Part L of the building regs, where they introduced that new combi boilers would need either weather compensation, load compensation, smart thermostats, or flue gas heat recovery systems. And now they've changed the regulations again. So on the 15th of June this year, 2022, they've changed Part L again, which has now brought in that they want to reduce the CO2 emissions of new houses by 27% and bring in low carbon heating and reduce the flow temperatures on boilers to 55 degrees to help combat global warming and climate change. So this is an outside weather sensor, commonly known in the trade as weather compensation. So all this does is tells the boiler what the outside temperature is. So how does it do that then? Well, basically they are an NTC, or a negative temperature coefficient thermistor. So what it does is it takes the outside temperature and turns it into a home's resistance reading and then relays that back to the boiler, which then converts that back into a temperature. The way this one does it is by a RF, or radio frequency. So at the boiler there is a sender receiver unit, and this goes on a north facing wall. Now technically the north facing wall is best practice. You can actually put these on any wall as long as it's in a shaded area. So you could put them on under the eaves, or you could put them behind downpipe soil pipes, or you can even buy a cover for them. As long as they're not in direct sunlight, they will work, but a north facing wall in shade is the best place for them. But there are other units out there which are hardwired, so basically it's just bell wire going directly into the board of the boiler. But the easiest way of installing these things is by RF, because basically all you're doing is screwing that outside to a north facing wall and putting the sender receiver next to it. Now, other manufacturers do other versions of this. So Glowworm do a version of this RF where it's got a little solar panel what charges the battery. Cool. Baxi do a version where the actual sensor is in your flue, sticking out, and then the wire runs through the flue into the boiler. So there's loads of different ways you can do this. Now, these aren't new things. These have been out a long time. I think 10, 15 years ago, Wiesmann were putting these in the box, and they still do. Every Wiesmann boiler you buy will come with weather compensation, and it should be installed. But one of the things we have found out about these is customers don't get used to them. And in the past I've had to come and disconnect a few of these because the customers have insisted on it, because these stop the boiler firing up. So if we do have a look inside this one, all you can see is there's a battery and a little PCB, which is how this sends all the stuff back to the sender receiver. So we've had these customers ring us and go, my boiler's not coming on, because spring, summer and autumn time we might get warm days where it's warmer outside than it is inside the house, and people want the heating to come on, but this stops the heating coming on. They basically need to just open a window or a door and let the heat from outside into the house. So people get a bit miffed with that they want to have control of their heating, but this stops them having control of the heating, because like I say, this magic little box will adjust the flow temperature of the boiler to suit what the outside temperature is doing. So obviously the colder it is outside, this is going to tell the boiler to go to a hotter flow temperature, and the warmer it is outside, it's going to reduce that flow temperature. So this is going to help massively saving gas, saving on that CO2, saving the planet, and saving us gas engineers in a job. Now let me just quickly try and explain exactly how these outside weather sensors are going to save us money, save us energy, and save the CO2. So basically, if we look down here, this is your room temperature and this is your boiler output on a standard time clock room stat system. So this is our given temperature, and you can see the room temperature goes massively up and down, and the boiler output goes massively up and down. So this is a massive waste of energy because we're going over temperature, under temperature, and it's not controlling very well. So the green colour here and the blue colour here, so the blue is the room temperature, the green is the boiler output this time using weather comp. So you can see they keep them pretty close together, and we haven't got these massive peaks and troughs where we're wasting energy, because anything above that 20 degrees is just a massive waste. When we're coming down too low, people are going to feel colder and they're going to start opening thermostatic radiator valves to maximum, turning the boilers up more to try and give them more heat, and that's going to send them even more over the top. So that's how weather comp actually helps us save energy, because it tries to keep everything close together and doesn't give us these massive peaks and troughs. Now that's weather comp compared to a standard room stat and time clock. Now you can't just have weather comp, you need some kind of time control as well. So weather comp works brilliantly with load compensation or smart thermostats. So let's have a look at the difference between the standard room stat and time clock compared to load compensation or smart thermostats. We have a graph. On this side we've got temperatures, on this side we've got times. This is with a room stat first. You've set your time clock to bring your boiler on between 6 and 10 in the morning and 6 and 10 in the afternoon. You've not done anything else. Now you've also set your boiler to its maximum temperature of 82 degrees. Okay, so the boilers are going to come on at 6. So 6 o'clock, depending on what temperature your house has dropped down to. So we're going to say it's the depth of winter and it's minus 10 outside. So the house has dropped to about 5 degrees, because we don't really want a house going lower than 5 degrees because water starts to freeze at 4. So it's starting at 5, and remember the boiler's set at 80 degrees or 82 degrees for the flow temperature, and we've set the room temperature to 20 degrees using a standard stat. What happens is that boiler turns on and it gives its full kilowatts. So whether it's 30, 24, 35, 50, because we can now buy 50 kilowatt combis, but say it's given the full kilowatts of 30 kilowatts. So it's going to go, whoa, straight up there up to the 20 degrees C at full burn. But what's going to happen is, because if you've oversized your radiators as well, what will happen is the room temperature will continue to rise, because the room stat, once it gets up to 20 degrees, is an on-off switch. But it's going to continue to rise up, and it could get to 25, it could even go to 30 degrees, because everything's massively oversized. And then the temperature will start to drop back down again. As it's getting towards the 20 degrees, it will shoot past the 20 degrees, and then the stat will click on about 18 degrees and do the same again. So then it's going to shoot up again, and it could even go higher this time. So you're ending up with the time it's on doing this till it gets to 10 AM and then completely shuts off. And then you go off to work. Now what's going to happen is the temperature now is going to plummet. It's going to start to come down again. while you're off at work or school or whatever you're doing. And it's going to get near this 5 degrees again till it comes on at 6 o'clock. And then it's going to do exactly the same thing again. It's going to massively overshoot and undershoot. And then as soon as it gets to 10 o'clock, it's then going to drop back down again and continue down from here. Now, massively wasting energy because the room stat only knows when to turn on and off. It doesn't know what the temperature of the rooms are, and because you've got the boiler set at 82 degrees, the boiler doesn't know. It's just going to give you the full kilowatts. Now, the average kilowatts in a property in the UK is about 8 kilowatts, and if you've got a boiler what's doing 30 kilowatts on heating, it's going to massively overshoot. So you're wasting loads of energy, even though you've got a time clock and you've got a room stat. This is slightly exaggerated, but that's what can happen. Now then, if you use an open thermostat, we'll do that in red. So, one thing here is with the stat, you can do a setback temperature for the night. And in the depth of winter, you don't really want your house going lower than, well, between 10 and 15 degrees. I don't allow my house to go lower than 15 during the depths of winter. Obviously in summer, your setback temperature will be down to 5 degrees because the lowest they'll go is 5 degrees. So, say we're in the depths of winter, we want it to come on at 6 AM, but it's been on all night because we've got a setback temperature of 15 degrees. So our starting point, instead of being down at 5 degrees, could actually be a starting point of 15 degrees. So all night our stat has been kept at 15 degrees, so our house has been quite warm. Can I just jump in here? What I really mean when I'm saying the boiler's been on all night, I don't mean it's been running all night. I mean it's just been capable of running all night with the setback temperature. Your boiler might not even come on, especially in spring and autumn time, but in the middle of winter when we've got really cold temperatures, your boiler might come on for a little short time to get it back up to that 15 degrees. So I'm not saying it's running all the time, because that would be a waste of energy. And I'm also saying when you go out, it's not on all the time, but your setback temperature is you set it to a lower temperature. I hope I'm not confusing you. Anyway, let's get back to this. Then what happens when it gets to the 6 AM, it starts to gradually increase the flow temperature. When it starts to get near the given temperature, it then starts to reduce the flow temperature. So it's trying to keep the boiler on all the time. So it will then nicely trickle just under the 20 degrees. When it starts getting to the going off time, remember it isn't really an off time, it then starts to drop down. Now if you've got a modern house built after 2008, it should be well insulated. So you won't have massive heat loss. So you can actually reduce your flow temperature on these boilers as well to 50 degrees. If you've got a house like a 1930s semi, then you might have to set your flow temperature to 60 degrees rather than 50. But the lower you can get that flow temperature and still keep a nice warm house, the more money you're going to save. So this start while you're not in is keeping it above 15 degrees, because if it drops too low, so say we suddenly have a sharp dip in temperature because it's gone really cold, the boiler will bring it back on and try to keep that temperature round about the 15 degrees. It then, when it comes back to the coming on temperature, it then starts to bring it back on and keep it just at this 20 degrees, and then obviously when it turns off, it drops back down and comes back to the beginning again. So you're using far less energy because you're not trying to bring the heating on full whap all the time. Your house is kept at a nice warm temperature, and this will save you an absolute fortune. Now in the UK, we're not got a mindset for doing this. Our mindset's for doing that. Oh, it's cold, turn that heating on for half an hour. And then let your house go cold again. Oh, it's gone cold again, turn it on again for another half an hour. Oh, leave it for an hour this time. No, that's not what we want to do. Now, standard room stats don't anticipate what the temperature is. They don't know what the temperature is on the inside, and they certainly don't know what the temperature is outside. But open therm stats connected to weather compensation as well saves you even more money, because it knows then what the outside temperature is. Now, some stats actually use weather stations to take a triangular of the temperature outside. They're not as good as actually using an outside weather temperature stat. So let's have a look at the stat what Glowworm can give you to work alongside this Climate Pro 2. The Glowworm wireless outdoor sensor intelligently communicates the outside temperature to the rest of the system to provide weather compensation, which will reduce the flow temperatures to maximise efficiency. The sensor is small and discreet, and no wiring is required between the unit and the rest of the system. It actually works on indirect sunlight, so it should be on a north-facing wall, which will recharge the small PV cells, so no batteries are required. Now, before installation of the outside sensor, it will need to be paired with the receiver. So you take this rubber bung off the receiver and press the little red button inside and hold it for 5 seconds. This will now start to try and pair with the outdoor sensor. On the back of the sensor there is another button to press, so you press that one. Once it's paired, it will flash green and everything's tickety-boo and ready to go. You can now install the sensor outside, and remember, on a north-facing wall. Now, actually, once you've paired the outside weather comp stat to the Climate Pro 2, we need to set it up. It's not just a matter of pairing them and that's it, away you go. So first thing we'll need to do is pick our flow temperature. So say we've picked 50 degrees. We will also have to find out what our average maximum coldest temperature outside is during the winter. So I've picked -5 degrees. So if we look here on this chart, which is given to you with the outside weather comp, so you can see down here is actually the flow temperature of the boiler. And if we look along here, this is the outside temperature. So here you can see I've picked 50 degrees for my flow temperature. And here you can see I've picked -5 for my outside temperature. So you can see I've drawn a line across from my 50 degrees up from my -5 degrees, and you can see it's fallen between 0.6 and 1. Now in this situation, because of where it's fallen, I would probably pick 1. And you would think that would be it once you've inputted that number into your Climate Pro 2. It's not as easy as that. It's a bit hit and miss when you're setting up these curves, because the customer might find in the first year they struggle to get the temperatures to keep the house warm if you haven't set this curve up properly, or you haven't set your flow temperature up properly. So it's a bit hit and miss, because you don't know what the U values of the house are, you don't know how much insulation is, and you've not really worked out the radiators because you haven't put them in. So when you're retrofitting a boiler, it's pretty hard to set this curve up first, but practice doesn't always make perfect. So when you go back for the first service, you might have to make a few adjustments. So that's setting up the outside weather comp. So with the information we've seen already in this video, let's kill a few of the myths that surround weather compensation. So the first one being weather compensation is impossible to set up and really hard to install. Well, no, it's not hard to install at all, depending on which system you put in. They're incredibly easy. Setting them up isn't hard to do, it's just a pain doing it, because sometimes you need to go back and adjust temperatures depending on the curve what's set. So the hardest part of installing weather compensation is setting the curve up. That's it. Another myth is the boiler flow temperature is reduced that much it becomes useless because of the heat loss in the building. Well, no. Basically, weather comp does reduce the flow temperature, but it compensates for the heat loss from throughout the building. And obviously this is where temperature controls inside the house also comes in. So yes, it does reduce the flow temperature, but doesn't reduce it enough to make it useless. It actually monitors it and keeps it to the heat loss of the building, because at the end of the day, that's what the boiler, the radiators are doing. They're replacing the heat loss from the building to give you a comfort temperature. And while we're talking about radiators, another myth is you need to replace all your radiators and all your pipework. Well, no, because a lot of the time radiators have been designed oversized massively by engineers over the years. So radiators could be able to cope with the lower flow temperatures to keep your house comfortable. So no, not every time radiators need to be replaced when your boiler is replaced. Another myth, as we've seen, you have to have north facing wall to put the sensor on there. And as you've seen in this video, no you don't. You can put them in a shaded area, you could even put them inside a deflector box. So that's another myth busted, that they only have to go on north facing walls. No, they can go on any wall as long as it's not in direct sunlight and gaining solar thermal, because that will completely mess up if you've got the sun directly heating that stat up. So hopefully this video has given you a bit more insight into weather compensation. Weather compensation is amazing. It's not going to save you millions of pounds, and it's not going to cut your heating bill down to zero with all these price hikes we've had. What it's going to do is it's going to help you as part of a series of controls to reduce your fuel bill. Installing weather comp, installing smart thermostats, reducing your flow temperatures, range rating your boilers. These are all things that can be done to reduce your fuel consumption and save you money, because you're saving energy. At the end of the day, it's down to the user to use these controls and have these controls installed so they can be able to reduce their fuel bills. If they don't use controls correctly, they don't have them installed at all, and they just turn the boiler on and off all the time, people think they're going to save energy that way. Yes, you're going to save a load of energy if you don't use your boiler, but what do you want to do? Be freezing cold, be poorly over winter just because you don't use your heating system correctly. So hopefully you've liked the video, hopefully you've gained some information from this video, and I'll catch you on the next one. Cheers.